the next in line is Bart, and I'm going to try this really, Skoronek, who has lessons from a non-digital world for us. And he will talk about some of the problems we have seen, and he will approach this whole thing from a non-digital perspective. Bart, the floor is yours.
Hello, everyone. How are you today? I hope the previous presentation woke you up a bit, because I also have a long series of slides you've seen a short preview. So my name is Bartłomiej Skowronek, but please call me Bart, just like Bart Simpson, except my family name is Skowronek, and I'm not from the US, but from Poland. And today I'm going to tell you about the bad design, and this is because I got a bit curious. Especially when, of course, when starting with preparing for the presentation, I tried to Google around, and the Google Wars told me that there are so many information about good designs, while it's quite difficult to find information about the pitfalls. So we have a lot of knowledge, and yet, guys, we end up with bad designs. How do we do that? Are we plainly stupid? Silence. Well, apparently we are. The building behind me is a building that won a title of the worst realization in architecture in Poland last year. This is because, as you can see, it fit overly nicely into the surroundings. But don't be misled, it won because there were more than one contestants to the game. And they are every year. So it seems that, well, the architects can be really stupid. The other example is a walkie-talkie building in London. It's been finished 2 years ago, and it's became really famous for being created as a concave mirror. So quite a few days a year, it reflected the sun, it directed it to quite a precise spot on the neighbor street, so to enable Londoners have their English breakfast outdoors, finally. And well, you might wonder, well, how could the architect know that? Because, well, it might be just a coincidence, you know, the sun, few days a year, and so on. Well, I wouldn't be so sure, because the same guy created a hotel in Vegas that did exactly the same trick. So I think it might do really with the Dunning-Kruger effect that says if you're entering a new area of knowledge and you're starting to learn, immediately as you gain a bit of knowledge, you start acting as a boss and you know everything and you can solve all the world problems. Only later on to be either put down to the ground or realize yourself that you don't really know anything. And afterwards, finally, you start to gain the knowledge and the self-confidence to finally become an expert. Another incidental anecdote here would be that it's quite similar to hype cycle the Gartner creates every year about the technology. And they say that at the beginning, when there is a new technology, it gets a lot of attention. It's an innovation trigger. Then it gets a lot of hype. Everyone talks it. It's a new golden hammer that will solve all your problems, and then unfortunately, it's a thorough disillusionment because it's not so easy to use. Later on, people start to understand how that design works, how that solution works, and then they are going to the slide of enlightenment, and finally, we stop thinking about the design, we just use it, so this is the plateau of productivity. But mind you, never underestimate the power of stupid people in large groups. My personal comment, and the second one be, no offense, we're in the zoo. But coming back to that prior knowledge, I think a great example would be from the aviation industry. At the beginning of time, well, after Montgolfier, Orville and Wilbur Wright, they started to fly. What you see here is a nice design of their cockpit, if you can call it. In order to fly that plane, you just lie down and you pull the strings to twist the whole airframe to make it work. It's not exactly user-friendly, to be honest, and the endurance in that was small for the machine, but also for the human. Later on, of course, we got a big incentive, and we started adding new essential capabilities like guns to the design. But during the First World War, what you can see behind me is that typical elements started to emerge, like a stick, pedals for the rudder. They moved on quite quickly because, well, they also wanted to be the fastest, the first one to cross the Atlantic, the longest flight, the highest flight, and so on. And, for example, Lindbergh plane looked like that inside. It looks quite similar to the previous picture, but interesting thing is over here, he had no visibility forward. There was just a tank of fuel in front of him, so they have worked around that with creating a periscope so he can actually see where he's flying. Brilliant design. And the Second War brought us a lot of developments, especially, well, in how fast you can kill each other, but how fast, how high you can fly. And to the left is a speed fighter. To the right, you have in the cockpit of the first jet fighter, Messerschmitt 262. And you can see they kind of get complicated inside. So the workload for the pilot also increases. And of course, that means that accidents happen because more and more technology and more is required from the pilots to get it working. Another example is the cockpit of B-17 Flying Fortress. It got so complicated that it actually required 2 pilots to be present in the plane to make it work. And yet, they have found out that they were crashing all over the time during the starting phases and landing phases. Landing, well, maybe not so surprising, but when you're starting up, everything should be fine, right? So they have figured out that, well, it's too complicated, and they have created a nice workaround. This is a checklist. That means that design was so awful and so bad that you actually need a cheat sheet to get it working. That's not the end of the story, because going fast forward, the Concorde, as it was usual at that time, required a flight engineer. So that guy sitting to the right, all he had to do is making sure that all the engines are okay, they are having fun, everything is correct, all the hydraulic systems are okay, and that really meant that you need 3 main crew members. So they are paid well, so that means that airlines are not happy, so they worked a lot to reduce it. So A380 right now is a glass cockpit, and really the 2 pilots are necessary only because we are afraid to put our lives completely to the machine. The same story for the Soyuz capsule. This is a construction that was created in the 60s, used till today. As you can see, the cockpit also changed. It simplified a bit, it changed a lot, but most importantly, it reduced the workload in the capsule during the critical phases. Same applied to the space shuttles. The first one was quite complicated, required a lot of attention. The last one that flew was way different inside, and well, I was told in Florida that it was way easier to fly and land as well. So they had a good incentive to develop something better, to go away from the bad designs. Unfortunately, not everything is the big incentive, and this is the toilet on the space shuttle. So what I would say here is that if you have no prior knowledge and you're just experimenting, that means you have some kind of an incentive to move forward. It's either the cost, it's either you want to stay alive, or you want to make your customers still alive because they won't buy another product from you. You might want to be first, higher, faster, and so on. And there is a driver behind it. There is a driver for a change. Although some say that, well, their designs are perfect from the very beginning. Of course, I'm making a little trick here because WADA, it's really a Fiat 125 from the 60s, bought by Russia on the license and produced for way too long. And it's been produced for such a long time because there are some limitations when you design. It's not always of total freedom for you. Another example is this, again, from my home country. This is something, well, when talking about limitations, to allow disabled people to get up the hill. Looks brilliant, really. Got to the news because this is the whole story behind it. And you may wonder why. This is because of the regulatory limits. Someone wrote in law that the inclines should be no higher than that amount of percent. This is the length of the road that it should be. This is how wide it should be. So meeting all those requirements ended up creating something like that. Of course, you might wonder why they just didn't put the elevator, but I guess the cost is another limitation here. There are some physical limitations, and we do tend to forget about them, or we do not check them prior to starting designing things. This also applies to IT, mind you. But that's not only a small thing. The big Mercedes behind me is an old S-Class, and it's called, or dubbed, the Achtung Panzer. It's because it was so big, so heavy that it couldn't fit into the parking lot, it couldn't fit into automatic car washing. Inside, the dimensions were also a bit out of hand. So it was the last model that Mercedes made so big outside and also in few places inside. The mobile phone is also a great example. We got from something really big to the point that we had phones that are so small that they were really difficult to use. Now we're slowly reaching the point that it's getting huge again. Some say that that might due to the fact that we found out that we can watch porn on them, so the screens got bigger. Of course, that makes me wonder what about virtual reality, because, well, I've seen a similar story with the screens as well. The other limitation might be habit. Anyone from the UK? I envy you, because you guys, you're so British that you refuse to do something that is just reasonable. They used to have a reason for that. I mean, the hot water was not clear water in most of the houses in the UK. It's not true anymore. Still a lot of new buildings are open with 2 taps in the UK. Of course, there are other habits. Automotive example. This is the Ford Model T. What you see is, well, something right now, a classical steering wheel. The little knob on the side is for controlling the ignition, something you don't have to worry about today. But the fun thing is there below. You're familiar with 3 or 2 pedals today, yet those 2 to the left, well, the leftmost is a gear change, the middle one is a reverse gear. The right one was supposed to slow the car down. You don't expect it to brake too hard. So it's not something that you would see in today's car, and this is because they have evolved from the bad designs a lot. But still, car industry is still experimenting a lot with us up to today. On the left side, you can see someone being true to the more is better, as on the previous slides, and these are the cars built today and sold today. Left picture is a Vauxhall/Opel. If you see on the highway an Opel from around 2009, 2010, that is just blinking randomly to the sides. This is because of the experiment they did, and they created an indicator that has just one click, whatever you wanted, whether 3 blinks or turn it on. No one never know. It was just like 2 years they have produced that. Below that is an experiment from Cadillac. They have created those switches there. I've heard that the guy that designed them is retired since then, and the knowledge what they do is lost. Then the other thing that all the solution is just create a big touch screen, and that makes me wonder because you're not allowed to text and drive, but it's okay to have a Facebook and a web browser opened up. I wonder when this is going. Of course, Car industry is also a good example of keeping us within those habits. And you can see more and more cars that are becoming kind of a generic cars. The designs, exterior designs becomes generic, interior designs become generic, and I think it's another extreme that you might go if you just stick to the habit. Yet the lesson here is that you need to give a user a very, very good reason to change their habits. Then, of course, another limiting factor is cost and time, and I think the triangle just sums up the topic. If you want something fast and cheap, it won't be good. If you want something cheap and good, it won't be fast. If you want fast and good, well, it won't be cheap. Of course, people tend to do things in a quick and dirty manner, so just Google "there, I fixed it," and you'll have just tons and tons of pictures like that and solutions like that. Quick hacks, really. We also managed to miscommunicate. I think that on top of that, we sometimes just stop listening to our end users. We just start designing and, well, everything goes well. And that also applies to our corporate communication. Guys, please, you also have to communicate between yourselves before you communicate outside of the world. This is a chart that is supposed to simplify a process. Yeah, you see where it's going. And talking about the corporate miscommunication, I think the example from Nokia is also good. Well, Nokia at some point of time, they had a brilliant idea that they are going to make a game console. They created that, they prepared the stage, they went live, and I'm sure that on the last day or day -2, they had a meeting internally and figured out, hey, we're Nokia, we're a phone company. And this is a game console, not phone. It should be a phone as well. Yeah. So as a last hack, you have a microphone over here and a speaker over there. Of course, because people communicate way better than corporations, that escalated quite quickly. Afterwards, and I think this was just a start of a Nokia downfall, you may wonder where Nokia is today. Unfortunately, I think they are back to basics. There are other ways to miscommunicate, like that ATM machine. I'm sure there's corporate regulation for the sticker about the rooms. The sign in Poland that you're supposed to read at 140 kilometers per hour on the highway. A yogurt, if you wonder. A vending machine that is just weird. It's quite easy to miscommunicate. Actually, there are quite a lot of ways to do a bad design there. I have to speed up because I was shown 10 minutes left. The other thing is, sometimes we don't gather feedback from the users. We just don't listen, we just create something, go it out, or we never listen. But I think there is another extreme to that. We are talking a lot about agile these days and how fast we should test, put out, make small improvements and so forth, to the point that some companies like beloved Apple creates a design that simply does not work under normal circumstances. As a good company, of course, they were publicized, so that also escalated quickly and was used by their competition to gain a bit of advantage. Apple, of course, denied it for quite a time. And you may wonder that, well, they weren't testing well one-off, but that came after the antenna gate, in which the previous version of the phone you should hold in a specific way to get a reception. Of course, the Nokia tried to play on that and said that you can hold their phones whichever way you like. But still, well, guys, try to communicate your mistakes and be honest about them, because it's not going to work in any way. Then Barbara Streisand effect is a strong one. So I think that at least I've tried to answer why we create bad designs. But on top of that, I would like to finish with a bit of a remark. And by telling you that there is a theory that says that our civilization just goes like a sine wave between mind and knowledge, Baroque and Renaissance, all over the time, so yin-yang type of thing. And for me, when I'm seeing the design, I think that it's important to have a little balance between how thing works and how they look. And my personal opinion on that is it should be skewed a bit to that knowledge part, because if you want all of your end user customers accomplish what they want to accomplish, no matter how pretty the thing will be, they won't use it. And on that remark, thank you.